This video is a sample problem of Newton's second law of motion and friction. A tube or the two blocks are attached to each other by massless string that is wrapped around frictionless pulley. When the bottom 4 kilogram block is pulled towards the left by the constant force P, the top block slides, okay, the top 2 kilogram block slides across to the right. Find the magnitudes of the force necessary to move the blocks at constant speed. Now we're going to assume the coefficient of kinetic friction between all the surfaces is zero point 0.4. Now we are given with this diagram. This is not yet the FBD or free body diagram or force body diagram or block body diagram. Now we have a 2 kilogram block which is on the top of the 4 kilogram block. Now as we pull this 4 kilogram block, okay, towards our left with a force of unknown P, it moves the 2 kilogram block towards right since they are attached with the same spring in a pulley system. Now, if we're going to bisect each block with their corresponding FBDs, for the 2 kilogram block, we have the following forces as the weights of the block, which is 19.6 newtons. So we got 19.6 newtons when we multiply the 2 kilogram with the gravitational acceleration 9.8 meters per second squared. This gives us 19.6 newtons. Now, the normal force is always the counteracting force of the weight, so it points upwards, okay, which is designated as N1. And since the 2 kilogram block is only moved by the tension of this cable, so we're going to name it as T. And since it moves towards our right, the frictional force is opposite of our tension, which is mu or the coefficient of friction multiplied with the normal force and 1. Now, for the weight of this second block points downwards as W. Okay? And then we have the weight as well of the first block 2 kilograms. And then we have the normal force pointing downwards for this one, which affects the second block or 4 kilogram block. And then we have the normal force for the whole system as N2. And then we have the tension here, okay, which is affected by force P. We have the coefficient of friction here since this moves towards our left, opposites for the first block as mu N1 and the second block as mu N2. Now, if we're going to proceed with our solution for the 2 kilogram summation of forces, we're going to consider this free body diagram of the first one as the weights 19.6 newtons with the normal force N1, tension T, and the frictional force mu of N1 normal force. Now, mu here is the coefficient of friction. Now, we're going to consider the summation of forces Fy is equal to the first mass or the mass of the 2 kilogram block multiplied with the acceleration. Now, since our problem entails constant speed. When we say constant speed, our acceleration is already zero. Why? Because we have the same values for the initial and final velocities v1, vf. Now, they are equal. If we're going to substitute whatever equal values for vf and vi to the acceleration equation, this gives us 0 all over unit time t. So this equates at to 0. Now, let's bring the following. Okay. Now we have the balanced equation for this summation of forces with respect to the vertical. Going upwards is positive and going downwards is negative. So N1 minus 19.6 newtons is equal to 0. If we're going to solve for the normal force N1, we're going to transpose 19.6 newtons to the other side of equation. So this becomes positive 19.6 newtons. Now, let's consider the summation of forces. Horizontal Fx is equal to m1 times the acceleration ax. I repeat, since we entail here constant speeds, our acceleration is 0. This makes m1 and ax equal to 0. So summation of f of x is equal to 0 now. Now for the vertical or horizontal forces for the fx, t, since this going to the right is positive and the friction is going to the left, this is negative. Now, this brings us to this equation as t minus 0.4 n1 equal to 0. If we're going to substitute our value of n1 here and transposing to the other side of equation, this gives us t is equal to 0.4 of n1 since we got n1 from the summation of vertical forces as 19.6 newtons. Now, T is equal to 40% of N1, 19.6 newtons. This gives us the following. The tension here is equal to 7.84 newtons. Now, for the second block, okay, we're going to consider the following as the values for the first block. Okay. Now, for the second block, summation of forces horizontal is equal to the mass of the second block, 4 kilograms, times the acceleration at the horizontal axis. Now, since this is constant speed, okay, our acceleration here is 0. So mass times 0, our equation equates to 0. Now we're going to consider the summation of forces x. Okay. Now, in this figure, forces going to the right is positive, forces going to the left is negative. So this is T, okay, positive T minus P plus 0.4 of N1 plus 0.4 of N2 is equal to 0. Now, since from our first block or 2 kilogram block, we already got the value for the tension, which is equal to 7.84 newtons, and N1 is 19.6 newtons. If we're going to substitute tension here, this is 7.84 newtons minus P plus 0.4 multiplied with our N1, 19.6 newtons plus 0.4 of normal force of the second block equal to 0. Okay. This gives us with the following simplified equation. If we're going to transpose the same variable, so 7.84 newtons plus zero point 0.4 of 19.6 newtons gives us 15.68 newtons. And then we're going to transpose it to the other side of equation, gives us negative 15.68 newtons. And for the left side of equation, we have the unknown at 0.4 N2 minus P. Okay. Now this gives us with two unknown as 0.4 N2 minus P is equal to negative 15.68 newtons. Okay, this is our first equation. Now for establishing the second equation, we need to sum all the forces at the vertical axis or the y-axis equated to the mass times acceleration. Now since this is constant speed, okay, so constant speed, our acceleration equal to 0. So 0 times the mass, our summation of f of y is equal to 0. Okay? So forces going upwards are positive and forces going downwards are negative. So as you can see here, N2 now is positive, a minus 39.2 newtons. Now this is the value for 0.4 of N1, or this is the value for the weight of this block. Okay, 39.2 newtons is 4 kilograms times 9.8 meters per second squared. This is the weight of the second block minus N1. Okay, so since pointing downwards. So we have N2 as upwards minus the weight of the block, 4 kilograms times 9.8 meters per second squared gives us 39.2 newtons minus N1 since N1 points downwards, equated to 0. Now, this is our second equation. If we're going to solve both, okay, since our N1 is already 19.6 newtons, we can get the value for N2. So this is negative 39.2 newtons minus 19.6 newtons, or this gives us to N2 minus 58.8 newtons. If we're going to transpose to the other side of equation, okay, this gives us N2 is equal to 58.8 newtons. And substituting this value for the first equation, this becomes 0.4 of N2, or 58.8 minus P is equal to negative 15.68 newtons. This gives us the value of P equal to 39.2 newtons.